Hello everyone. Welcome to the talk about Castle game engine. I'm Michalis Kamburelis, and I've been developing this thing for like 15 years, a bit more actually, but I'm ashamed to say how much. So thank you first of all for coming to the talk. I know that custom game engines, not so very popular ones, are not that hot a topic, but I do hope I will have some useful information for you. I kind of wanted to talk about two things really during this talk, so I hope I will squeeze it all in my half an hour. I really want to emphasize two things. One is I want to tell you how it basically goes, why I did what I did, and what decisions I made, and what were the benefits and drawbacks of everything that I did. And the second thing is I hope that this is also a practical thing. I mean, the engine exists, it has been used, it is used to develop well-released games on various platforms, Steam, Android, and so on and so on. So it's a practical thing. After this presentation, I will show you how it works. Go ahead and also download and check it out yourself. You can use it to create working games, and I hope that you will enjoy it. Okay, so that being said, now I'm going to try something impossible, which means I'm going to try to actually do a live demo of the presentation of the engine, and we'll see how it goes. Also, we'll see how it goes with time, and let's jump into it. So this is the engine. Basically, the slogan of the engine is that we have a powerful, we have a comfortable visual editor to edit your stuff, 3D and 2D, and we also have a powerful code API. And I'm going to quickly show you both. Okay. So the basic way you would use the engine is you create a new project, you let's say create a new design. In this new design, you create a three-dimensional viewport, and here you go. You create something like a transformation. For example, it can be a box. And you can do it like this, okay? So now you can do some more stuff. For example, we can duplicate lights like this. You can move this light here. You can activate the shadows here. Let me click on this checkbox. You can go ahead and make this plane a bit larger like this, okay? So nothing fancy, right? So let's turn off the physics. How do you turn off the physics? Well, you may know this already from some other engines. We do take inspirations from, well, a lot of things actually. So let's activate on this thing rigid body, on this thing rigid body too, and let's make it a plane collider, okay, amazing. And now we can run a physics simulation. Oops. As always, something doesn't work. Why? I'm going to ignore it, okay? Because I do prepare a contingency, so let's actually try this way. I predicted that I will fail, okay? So if that's okay with you, let's try how I did it yesterday, and exactly the same thing worked. Well, actually, I did click something stupid right now, right? And I have no idea what. I don't have actually time to debug it, okay? So let's see, and maybe you will help me, okay? What did I do right here that I did wrong like a minute ago? I will have no idea. But maybe you'll help me. Okay, let's resize the plane. I can see it also here. Yeah, what did I do different? This is the plane, this is the rigid body, and this is the box. And the box collider, and the rigid body, yeah. And the desired effect was this, yeah? I have a question to the audience, yeah? I have no idea the answer. What did I do differently, like 30 seconds ago? No idea, but I clicked some, unless you really know. No, okay, then nobody knows, okay.
Gravity is on?
Yes, gravity is on by default, actually, on all of those things, but the plane collider is static, by default.
I believe that rigid body was added first for the collider.
And it should work in any way. It should work added in any order. But then, okay, maybe it's a bug, okay?
The box was already on the plane.
Yes, you're right. I think that's it. Okay, okay. So everything worked. Okay, so it was perfect. Okay, just yeah, that's actually yes, probably. Okay, but you can see now how it goes if I would do it correctly, right? So here I added just to So I have added a sphere collider at the end. You saw that. And the sphere collider, what it did is it kind of hit the ball. I mean, the ball was flying and it hit the boxes, and well, the physics was working, right? The boxes collided and everything collapsed, and it was fun. So I do have some more demos. Let's try these ones now. Okay, let's see how it goes. So this was I guess, an unimpressive empty viewport. Let's try some other demos. All right, so this is like a more filled out, I guess, template of our three-dimensional game. And here again, you can kind of do the same thing. So what I want to talk about here, well, we have models. This is kind of a castle scene. It's loaded from a glTF file. I will talk kind of a bit more why we chose the glTF format and why I think it's a great thing, basically. We can switch animations, obviously, so we can do things like that. You can duplicate stuff, so you can go around and do it like this. You can create more light sources, obviously. So let's go ahead and add a spotlight. It works like this. Let's rotate it a bit. All right, and just to make the effect like more emphasized. Okay, 100 would be maybe more than we need. Okay, so that's like a simple demo that you can do this thing on like a, well, it's not a finished thing. Yeah? It's still kind of a programmer art constructed by something more prettier. Yes?
Is that the second point light with shadows?
No, right now, no. I mean, this is the one. This is the first. This is only the spotlight casts shadow volumes. This checkbox we plan to extend it to allow both shadow maps and shadow volumes. We have shadow maps actually implemented since like many years in the engine, but it's not yet available through the simple checkbox. But it's actually my desire to make it available this way. So right now, just the spotlight casts shadows. Okay. What more did I want to show here? Well, we can have something like basically, we can edit the camera actually. So for example, if I click here, I can also pin it. I can see what the camera is basically seeing, okay? And I can like move the camera whenever I want. For example, maybe I want the camera to show this view, okay? So I can like align the camera with what I'm seeing currently in the viewport. What more can I do? Well, we kind of have something like Unity prefabs, which means that, for example, let's construct some hierarchy. So let me duplicate this thing. Let me say that what I really, really want is I want to have a soldier with a box, okay? Because for some reason, that's like an amazing prefab that I want to prepare now, okay? So the way I would go around about it in Castle Game Engine, and I can save it, I can call it my, because that's, I guess, well, where my imagination takes me today. So this is like a prefab, okay? So I can edit this thing. I can edit this thing like independently of, well, everything else in my scene. I can save it. Now I can go back to my design and I can like drag and drop it on my scene. Oops, sorry. Yeah, and now I can drag and drop it on my design. And this way I can use multiple times my prefab, okay? Well, it's not a prefab. We don't call it prefab. I didn't want to call it prefab, but it is like prefab if you come from Unity, okay? So we can have something that is essentially a container that is reusable multiple times, and it contains a design of multiple components in our case, okay? What more do we have? And it's kind of an important thing. So we have something like a behaviors. Those are things that can be attached to a transformation things. And one example of a behavior would be the billboard thing. For example, let's drop an image on a scene. Okay, got that huge. So let's make it a bit smaller, like this. And this is the image. Oops, sorry. All right, so this is the image. And now I can add here a behavior, which will make it behave like a billboard, okay? So it just works like this. Now, this is not a very fancy, this is not our most fancy behavior, I guess, but the thing is that, of course, you can use it also for programming. I mean, the name behavior is deliberately kind of similar to something you know from Unity, and yes, you can create your own behaviors from code, and you can attach them to existing castle transformations, and I guess this is one of the easiest way to actually implement something like, for example, AI. Anything that drives a three-dimensional or two-dimensional model throughout your world, well, that's a good idea to implement this way, okay? So we have those things, and I see that I'm short on time, so let me just show next things during the movies, because those will be quicker. I think I actually managed to do it correctly, but I just like to talk. So it will be faster if somebody else will be showing the movie and I will be talking over it, okay? So now this is the two-dimensional movie. It really works the same as a three-dimensional movie, not a movie, a game, where we can transform. I don't know why I scaled this dragon, but the thing is that we have two actually ways of making animations. I mean, we have a few ways actually, but one way was the glTF, right? We already saw that. Now the dragon is using spine animations, which means that they are smooth. And this mesh, this disciple, it's kind of using sprite sheet animations, which means that each animation is a sequence of images. And we have our own editor for sprite sheets. So we can design sprite sheets, you can make a smooth animations from this Spine or Blender, and you can use smooth transitions, so we have like cross-fading of those animations. And yeah, I kind of think you have like all the techniques available at your disposal. And here you can see I actually at the end like run the game, yeah, because I didn't do it so far. Yeah, but the ultimate point of all of this that I'm showing is that you design something, you click compile and run, and that's like 2 seconds, and it actually runs you a working game. So that was the last piece of this demonstration. Now let's go ahead and switch to this last thing. Again, I will just read the slideshow. I mean, I will let the movie kind of run, and I will talk over it. So how would you go about adding the code to your game? Well, the thing is that we have 2 subdirectories in our project, data and code. What I'm editing right now is the data, and I'm creating a component called this one. The name, this one, is kind of important for me because this will be used by the code to actually refer to this component, okay? Well, that's actually similar to, well, pretty much everything else that you know, okay? And what I did now is I just double-clicked on the Pascal file that corresponds to the state. Here I'm going to declare a variable with a name deliberately matching the component that I have designed. And now I can go and do anything with it, okay? So the simplest example, the simplest thing I did here is I just went to the press method that says what happens when you press a key or a mouse button. And I said, okay, when you press an X key, then change the animation of this thing to die. And it's not a looping animation, so just play it once and then it will stay at the end. And there you go. Now I'm running the game. I'm running the game. I click, click, click. Okay, and now when I press X, this animation changes to die. And that's like, I guess, a 5 seconds, well, not a 5 seconds, but still a quick demonstration of how you would go around modifying your code. So it's easy. You have access to all the components that you have named, and you can do with them whatever you want. I emphasize like the behaviors are often like the most scalable approach, right? Because you can attach those behaviors to anything you want, and they kind of live connected to this transformation. So, okay. So that was half live, half videos demonstration of how the engine actually like works, and I hope it like it's nice. Okay, so now a bit of slides about that I want to show you how like a context of why I did, and maybe some like broader ideas. So basically, why I did my own engine, right? I'm crazy. So I wanted to have an open source game engine that is like 100% open source, including tooling and everything. Back when I started, actually Godot didn't exist, so if you want to raise that argument, it wasn't there yet when I started. I wanted to have one good language. I mean, I'm kind of arrogant, so I think that, God's sakes, we should have like one language that we say is good, a general purpose, and it's really good to develop your games, to give it to the users, and it's also good to develop your engine. I mean, I'm kind of imagine that in the ideal world, we should just have one language. And I'm not saying like Pascal should be this language, but I'm saying that it would be nice if you just have one language, you know, instead of choosing one language for scripting and another language for engine development, because one thing is comfortable, the other thing has performance. I want to try, can we have an engine that has both? I mean, can we have a language that has both, okay? So that was my kind of dream, and I kind of hopefully proved that it's possible. And then I wanted to use open standards for data formats, and I actually have a few more slides about it. So back when I was started, I mean, this is one decision. Yes, this is one decision that I want to talk about that I made, why I made it, and whether it was a good thing. Spoiler, it was a good thing. Using open standards. So back when I started, I think it was more than 15 years ago, I kind of looked what Blender can export to. And it had a number of like very strangely limited format. Popular, but why? They were limited, like 3ds and Wavefront OBJ and so on. So I thought about using another thing called VRML1. Blender could export to it, and then I saw a very nice property of this format. It had a specification. I can read it, and it's really a good specification. It describes what you should do with this format, and everybody like has a fair ground. Me, a lone developer, and the Blender, okay? at that point, well, maybe not that big, but still much bigger than me software, okay? Everybody has a fair ground, like implementing this format and making it right, okay? So that's a great thing about specification. And it was actually like good. I mean, it was scalable design, what I call here, because it was obvious that it was based on something else. It was based on Inventor, and it was obvious that there was a lot of thought put by people, well, much smarter than me, how to design a proper format that kind of survives throughout the years. VRML1 is kind of ancient and, well, dead essentially at this point. I have moved to X3D, which is kind of a successor of it, and the glTF, but kind of the reasons, so yes, this is a point of a joke, yeah, we had one standard, now we have more, yeah, but that's still good, I mean, because we have now more standards, they are great, they kind of learned their lessons from the previous standards, and the reason for choosing open standards still kind of stays valid. We have a lot of tooling available around this format and around those open formats, yeah, and we benefit from it greatly. I will give one thing from it. About my history, well, I did a few improvements around X3D. That's a GIF here with the water. I did something like compositing shaders. This is a shameless self-promotion, yeah, so I did something like all the stuff is shameless self-promotion, but this slide especially. So I did compositing shaders. This is like essentially a Unity surface shader, but a bit better, which means that you can kind of define an effect that you can implement in OpenGL shading language, and you can like put multiple effects on your shape in any way you want. Like you can maybe have a Fresnel effect, you can have a water effect, you can have a fog effect. You can choose any one of them. You can just put them on the shape, and they will be combined into, well, in the end, into one bigger shader that just works. So I'm kind of happy with it, and basically I stayed a bit and I worked with Web3D. They developed the X3D standard, and with Chronos, they developed the glTF standard. And what you really, I guess, maybe want to remember from this is that glTF is a great format. We kind of focus on it extensively right now in our development. It has a great design, great set of features for us, for like game development, skinned animation, physical-based rendering, efficiency to read it, okay? It's suitable to be read at the runtime, which is kind of important. Many engines kind of take your data and they transform it before they actually release it to runtime, right? Because, you know, I don't know, FBX or anything, it has licensing issues and, well, maybe some other performance issues. glTF doesn't have that. It's a good format that you can just load at runtime. It's an efficient format to load at runtime. So you don't need to process it. You can just load it at runtime. Okay, and like one thing that I mentioned about nice stuff about tooling, right? So the one feature that is coming to the Castle Game Engine, I hope within this year, because it's very cool and I want to make it, is integration with Sketchfab. Sketchfab is this, it has some paid models, it has some free models. The gist is that you will be able to like type in a search box in Castle Game Engine, for example, I want to make a room and I want to have a chair, a table, a coffee pot, whatever, yeah? And you can kind of type this into a search box, you can drag and drop it on your scene, and well, it will work. Well, it will work because Sketchfab is actually has an API to enable searching and to enable distributing, downloading the models from Sketchfab in the glTF format. Okay, and then we can load the glTF format. So just one example, I think a powerful one, of how using open standards helps you interoperability, and this just translates to the features, to the useful features for users. Okay, so the other big decisions, I guess, let me see how much time I have. Not so much. I will try to speak even faster, okay? So the other, I guess, big decision that I make, and you may wonder why, is choosing Pascal, okay? So just to be clear, I'm not like a religious person about Pascal. I don't think it's the, okay, I think it's a good choice, but I don't think it's a perfect choice. I have no idea what is the perfect choice, okay? So I will not say that Pascal is perfect, but it is a clean type-safe language. I mean, you have a static typing, everything is checked. It kind of looks clean. You can go low level, you can go to pointers and stuff, you can do pointer arithmetic if you want to, but you kind of have to be explicit about it. You have to do typecasts to actually do that. So I do think that it's type safe, although it allows you to go low level, and that's a nice thing. The advantage I already mentioned, that we can have a code of the engine and of your games using the same language. You can have developed them using the same language. This is especially important for an open source project, because it means that all your users are also your contributors. Like, you know Pascal, you can write this game. Great that you can write a pull request also to improve something in the engine. Pascal is compared to the native code. That's like, I guess, a historical thing, but we benefit from it. Yeah? So there are no like multiple intermediate steps before your Pascal code is translated into something that CPU consumes. It's just one compiler that, well, it has multiple steps inside, but it's still just the one compiler that does those steps efficiently. Okay, so that's good. And the Pascal is old, which is sometimes a problem, but you also know some older languages, but it's also a benefit, right? Because there are a lot of existing libraries to basically do everything, like XML, database, blockchain and AI, hot topics. Okay, so we have a lot of like existing stuff to do, things that you can imagine that is beyond our scope of the game engine, and you can just use them in our game engine. Like if you want to interface with MySQL in your game, well, go ahead, there's a unit for it, yeah? And I didn't make it, somebody else did, and it's great. And we can integrate with any existing library. So like if you have a library with a C API, you can just use it in Pascal. That's no big deal. You can just link to it statically, dynamically, and you can use any API you want, which is of course the way how we use, for example, OpenGL, Steam, OpenAL, and a lot of other libraries. Oh, and the bottom right corner, that's a screenshot from Not Quake. That's I did it for a game jam. It's a multiplayer real-time simulation, real-time 3D shooter developed using RNL and open source real-time networking library. I wanted to see, can I make something like a Quake? I kind of did. It took me 1 day, so I was extremely happy with it, and it actually works over the internet. It's using Castle Game Engine for like, well, everything except network. And for the network, it's using RNL, and it works. Okay, and I guess, okay, I warned that I'm not religious about Pascal, but I do mention a few benefits from it, okay? So this is, I guess, another slide about benefits. So we really have a fast compilation. Like if you compile a clear project, like you click new project, compile, you actually saw it, okay? On the movie, I don't know whether I did it on the movie or live, I don't remember now anything. But it's really fast. It takes 2.5 seconds to build a project for Linux. It takes 10 seconds to build from scratch. 10 seconds to build an APK for Android that works on both 32 and 64-bit systems. You're kind of welcome to try whether your workflow with your engine gives you these same speeds, and those matter, right? When you're iterating on the idea, it's kind of great that you can just hit F9, it's a standard shortcut for compile, and you just have the game ready, yeah? It's compiled to a native code, but it's really, really fast. Okay, and if you don't know Pascal, because I suppose many of you don't know, or maybe have learned some weird version of it in school, like, without object and so on, I do have, well, there's a lot of information on the internet. I also wrote one. That's a modern Pascal. That's kind of an introduction to Pascal for programmers. If you know Java, C#, C++, it's really extremely similar. Those are the same concepts, wrapped in a bit different syntax, but not much different, okay? So if you're curious about Pascal, go ahead and look at it, because it's kind of, straightforward, I think. Another things that we have, so automation, yeah? So I think that automation works, and it's kind of free for open source. So we have this nice integration with GitHub, GitLab, we have Docker containers. You have you can use one file, put it in your repository, commit it, and then GitHub will build projects for you. That's not specific to Castle Game Engine, but we kind of take effort to actually give you a ready file that you can just put in your project and achieve it, okay? So use the automation, it's great. Cross-platform, so I think or not, I mentioned that we work on various platforms, desktops, that includes Raspberry Pi, mobile, Nintendo Switch. We also have coming, like Oculus, WebGL, Xbox. And because the compiler for WebGL is also ready, to WebAssembly. So we have more platforms coming, but I hope that even our current scope is nice. Okay, so now a few more slides about a broader context. I wanted to say okay, I guess some conclusions from this trip that doesn't end, never ends, I guess. So evangelizing your technology. So this is a nicer word for calling for marketing. Yeah, marketing is I sometimes don't like this word because it means saying something to promote you. Evangelizing is a better word, and if you're going to develop a bigger project, I guess think about it, because And especially if you want to Google or DuckDuckGo something about after this talk, then Tech Evangelism with Gabriel Gonzalez is kind of eye-opening talk. The gist of it is that you should develop your thing to like have a small core, and this core should be great because nobody is going to use it if it's going to be non-optimal, because there are probably other optimal solutions. So focus on some vertical market. That's a marketing speak, I guess, and then make it great, make you competitive in this market. And then the next thing is kind of think about, in game that we would call this elevator pitch, yeah? But in general, it's like a slogan for your thing, yeah? So what do you want to emphasize that you can actually do? And now here is the important part that kind of opened my eyes. This is not just marketing. The proper way to do this slogan is that it sets your priorities. It's a compass for all your priorities. If you figure out what you want to do, this should be your compass for, I don't know, a week, a year, a few years, but it should be your compass to everything you do. So it's important to have it. And have fun while doing it, because I guess it will take a long time. So I will try to speed up even more than, okay. No, but seriously, I would then try to skip some things. So declarative. Declarative approach is good because it means that you think that things have properties, not actions. And that's just simpler to explain to everybody and to use. It also means that the things can be serialized. They are friendly for editor, for tooling. So I kind of encourage you to think about your APIs as being declarative. So not a complicated set of calls, methods that call each other. I mean, you will have those too, sure. But first of all, think about structures that have properties and are interconnected. That's kind of scales better, and it's simpler. And Pascal is actually good for that, because Delphi, like from the beginning, was like designed to allow exactly this. Components have runtime type information, and this way you can have this object inspector that displays all the properties of the components automatically. So like whatever you do in Pascal, you can also see it in the editor. And we use it too in our Castle Game Engine editor. OpenGL still rocks. That's kind of my thing. Like, we have a lot of like incredible new technologies. Well, okay, I'm maybe not like some of those mentioned here, but I very like Vulkan, right? I am excited about Vulkan. But the thing is, if you want to be practical, OpenGL still works everywhere. I mean, here OpenGL like family. OpenGL, OpenGL ES, WebGL, it's a kind of a family of APIs. They still rock because they achieve what they have promised. They work everywhere today, right now. So that's, yeah, go ahead and using. And I guess this is just the final slide. It's a really nice thing to be kind of controlling your technology. It's nice that you can like do what you want with the performance you want, with the focus where you think it should be. And it's kind of amazing when it comes together and actually allows you to do more stuff. And that's it. I made it in almost 30 minutes. Thank you all very much. I have no idea do we have time for questions, because I think we may be... we have 3 minutes. Excellent. Then go ahead and... Yeah.
Oh, 1, 2? Okay. Was it hard to get a dev kit from Nintendo Switch?
Surprisingly, no, actually. Although I did not get a dev kit for Castle Game Engine specifically. I don't know if they would answer like, hey, I want to develop an engine, give me a dev kit. What we did was I'm also a CTO of a catastrophe games company, and we developed games there. In particular, we developed The Unholy Society, a game using Castle Game Engine. So we said today, hey, we didn't emphasize that we're making a custom engine. We emphasized that we're making this great game. And they said, okay, cool, that's your dev kit. I mean, no, that's your dev kit, that's your entrance, yeah, that's your login, yeah, and then you can order dev kit. So it was surprisingly easy. There was probably a bit of luck here also, because I think they just sometimes have limited stock. I'm speculating here. Okay, it was surprisingly easy for us, no problems.
Thank you.
Hey, I don't know if I saw correctly, but does the components are components part of the hierarchy? Like, yeah, and
yes.
And the big hierarchies, isn't that complicated? That, you know, normally like in Unity, for example, you have big hierarchy of like prefabs and stuff, but all the components are in the inspector. Exactly. And here I would imagine that it is like in the same place. So isn't it like a problem in a big hierarchies.
It is a UI problem. I mean, essentially, especially if you go with a lot of behaviors, like for physics, and you are going to do that, yeah, the hierarchy gets kind of big. It is a problem, and we have a way to address it. Basically, those are not components of the same class. It's a hierarchy of T-Castle transform, and then and that's kind of like a game object in Unity. And then inside the Castle transform, you have a hierarchy of behaviors. And that's kind of like a component in Unity. So we can split this. We can display the hierarchy of transformations here, and maybe on the bottom, maybe on the right, we can display the behaviors. So we can have here UI that we want. And yeah, those are different classes. So we can tweak it, so we can change this UI like consistently in to be better. That's a fair point. It's a to-do, basically. That's the answer.
Thank you.
Okay, so thank you for your presentation. And I got one non-technical question. Like, what motivates you to do game engine for 16 years?
It's more than 16 still. I don't know. That's a hard question. I don't know. I kind of wake up and I think that I'm going to make something good, and then it takes 15 years, but I still think that I can make something good. And really the dream was, I'm not a fanatic maybe, but I do like open source, and I do like that I'm making something that is open source, and that hopefully will be useful for more people. I don't know if that's a perfect answer. I don't know what drives me. I don't know. I just think that it's nice to develop something, and it's great that it's going bigger and actually useful. Yeah. Sorry, I avoided the question. I have no idea. Wasn't prepared for that. I like doing it. That's a short version. Yeah.
It's a great answer.
Oh, sorry, I don't hear you. I think we're really running out of time.
Actually.
Yes, thank you all very much. I will be outside if you want to ask me any questions.